Hi there, everyone. Welcome to African Hope Learning Center online sessions. It's me, Elijah, and today we shall be talking about simultaneous equations by eliminations method, which is called cancelling by additions. And so, actually, we will be talking about eliminations here using multiplications, and because in the first video, I showed you how you can just do the simple additions for the simultaneous equations if you have if you want to eliminate one variable that have the same coefficients and have like a different signs, or the same coefficients but different signs, so we see how that come out evenly. But what about for the case when you have like equations like this one, whereby the coefficient of x is not anywhere close to coefficient of x down, and the coefficients of y in the alpha equations is not anywhere closer to coefficients of y in the down equation. So what do you do in such a situations? In such a situation, we have to do a multiplication. And what is it that we multiply? We have to first of all identify the equations that we need to eliminate. Okay, I mean the variable that we need to eliminate. And if we want to eliminate x, then you identify the coefficient of x in the top equations, and then the coefficient of x in the bottom equations. Take the coefficient of x in the bottom equations and multiply by the equation in the top equation, and then take the coefficient of x in the top equations, and then you multiply by the bottom equations. So this is basically what we do. So how does solving by eliminations look like? So you have now this equation, which is 2x plus 3y is equal to 12, and x minus 3y is equal to 6. So this system of equations could be solved by eliminations. So it can be solved by eliminating the y variable through additions. Okay, so like now here you have 3y and another 3y, and they have opposite signs. So if you add this one, it will give you 0, and definitely we would have eliminate y. Okay, so also this system of equations can be eliminated by can be solved by eliminating the x variable. So how do we eliminate x variable here? Since they have the opposite sign, the same signs, we have to introduce something that will make them cancel out. And what we do here is negative. So this also applies if they were all negative numbers. You would just put subtractions, and then automatically one negative will neutralize with this minus sign, and then you will still have 0 being cancelled. So previously we learned how to solve equations, solve system of equations by using addition or subtraction, which eliminates one of the variables. Because we need to eliminate one of the variables here so that we only remain with one variable, and it will be very easy to solve one variable. That's the reason for doing that. So since this system of equations cannot be solved by elimination without addition, or elimination with subtractions, I mean, how can we solve them? Okay, so here this system of equations, there's no way that we can do the additions here or subtraction whatsoever, because the coefficients are not close to each other. So what we do here is that if the top equation was multiplied by 3, okay, we take this 3 and then we multiply by the top equation. Then the first term would be 3x, okay, and the bottom equation could then be subtracted from the top equations, and that will eliminate x here. So let us try to do that. Here you have 3x plus 4y is equal to, 3 into 3x plus 4y is equal to 3 into 17. So inside the bracket here, and the bracket means multiplication. So it means these 3 can be multiplied with everything that is inside this bracket. So we take this 3 multiplied by x give us 3x. 3 multiplied by 4y give us 12y. And then 3 times 17 give us 51. So it is these 3 that we multiply with all this to get this new equation, which is 51. what do we do? What do we do for this equation? For these equations, we do nothing. Why? Because the coefficient here is 1. So even though we take that one and we multiply throughout here, you will still have the same equations. So we have now the new system of equations with 3x plus 12y is equal to 51 and 3x minus 2y is equal to 9. So now you can possibly eliminate this x variable here because it is having the same values. Since it has the same values and the same sign, you have to do the subtractions. Okay, so in these new equations you have 3x plus 12y is equal to 51, 3x minus 2y is equal to 59. So we are going to subtract the bottom equations with the from the top equation. So we are subtracting 3x from these 3. So it is 3x minus 3x, which gives us 0, I believe. And then 12y minus. So this minus and this minus neutralize each other and you'll get like 14. So you have like 14y here is equal to 41 or 42. So the next thing now left for you is to find the value of y. So how do we find the value of y? We are going to divide both sides by 14. Okay, so we divide both sides by 14 by 14. Now if we divide it 42 by 14, definitely you will see that you get something like y is equal to 4. So now we are going to solve for x. So how do we solve the x? We take this equation, we take this value here and we substitute it to one of the equations. So we take the first equations, which was 3x minus 2y is equal to 9. So we are going to take 3 here and we'll plug it into in the place of y. So if we plug it in place of y, you just have to multiply that. And you have 3x minus 6 is equal to 9. So what are we going to do? We have to add the 6 on both sides so that we eliminate this. Okay, we add 6 on both sides. So if you add 6 here, you will definitely get 0. And if you add 6 here, you will get like 15. So you have 3x now is equal to what? It's equal to 15. So we add 6 to this side and we add it. So sometimes you just do it linearly or you do it by side by side. So it doesn't matter. If you do it vertically, the problem here is that you have to know the reason for adding 6 on both sides. It's just to get rid of this negative 6. So if we want to get rid of negative 6, we have to add a number which is of the opposite sign. That's what we call the additive inverse in math. We give you 0, and then what we do on the right hand side of the equations should also apply on the left hand side. So if we add positive 6 here, we have to add it on this side too. So if we do that, then you will realize that you have like 3x on this side and then you have like 15 on this side. So now let's find the value of x. So to find value of x here, we have to divide both sides by 3, both sides by 3. And then definitely you will get something like 5. So y now is equal to 5. So can we prove that? So here is the proof. We have the equations, okay, the original equations, and we now have the values of x and y. So if you take 5, okay, for x in the first equations, and then 3 for y in the second equation. So put, in the same equation actually, put 5 here and put 3 here. So if we are going to have 5, 4 times 3 is something like 12. So if you add it, then you will definitely get 17. So if 17 is equal to 17, this equation is satisfied. This condition is satisfied. It is correct. What about if we put 5 here? 5 times 3 minus 3 times 2. So this is 5 times 3 is 15. And then 3 times 2 is something like 9, like 6. So if you say 15 minus 6, then you get 9. Okay, you get something like 9. 9 is equal to 9, and then the situation, the condition is satisfied. So in most cases in the Sudanese book, they will ask, if they give you a question like this, they will ask you to find the set of the what? The set of solution for the simultaneous equation. So if they give you a set of solution, Then make sure that you write the coordinates later at the end of at the end. So you write the curly bracket and put them inside the bracket and write the what? Write the sets or which with these coordinates. So what it is that. So solving by eliminations like these from the previous equations, okay, it is not must that we must multiply all by the coefficient of the other. You just have to think of any number that you can multiply with with any of the equations so that it make the coefficient equivalent. So what again can we do? Is it possible for us to multiply the top equation by 3? Yes, it is possible. So if you multiply that top equation by 3, then it will give you something, okay? And then if you multiply the bottom equation by 2, then you get something like 6x minus 4y is equal to 18. So now what have you made to be the same here? You have made 2 to be the same here, okay? It's 2. 4 and 4, so you have 4 and 4, so it can be very easy to eliminate y now, and this someone should try it. You can try that, and I believe you will arrive at the answer. So what are the summary of steps? First of all, arrange the equation with terminal columns, then multiply one or both equations by appropriate factors so that the new coefficient of x or y have the same absolute value, okay? And then add or subtract the equation and solve for the remaining variable. You add, subtract, or subtract, and then you solve the remaining variable. Then substitute the value for that variable into one of the equations and solve for the value of other variables. And then you check the solutions in each of the original equations. So that is the summary. So here are these questions. I believe you had tried them. So this is problem 1. As you can see, problem 1, what did we multiply with? What did we want to eliminate? Eliminate this, so we multiplied this second equation by 4. And then this was what we got, and then we subtract, and then this is 0, and then this is negative 11, and then this is negative 44, and then divided by 11, negative 11, negative 11, you get y. And then you substitute that value of into the first equations and or the second equation actually, so that you get 8 subtracted from the other side, you get x is equal to this. So it's simple like that, okay? Look at this. Look at, multiply the bottom by 4 to get the news, and then subtract the bottom from the top equations, and then solve for y, solve for x, and then that's it. So they still in problem number 1, you can check in your values and then proof, and then you will be fine. So this is also problem number 2, okay? Problem number 2 is multiple of 6 and 8. So you have 6 here and 8 here, but these are large numbers, okay? The lowest common multiple of 6 and 8 is 24. So multiply the top equation by 3 and the bottom equation by 4, okay? So we can multiply. It's not necessary that we must take this one, okay? Just look for the possible small numbers that can, but it will be more appropriate if you just take those numbers. But for this case, let us take 3 and 4. What is 3 top equations? And then you have that, you have 48 plus 24y is equal to 36. And then 4, and then down equation, you have these things. Now you can easily subtract. Now if you do the subtraction here, can you see that everything is going to cancel out? Boom. Everything get cancelled out in the other equation. So definitely we have problems. Same to this one here. So if everything get cancelled out, then just know that there is no solution to the system of equations like this. That means these two lines, okay? These two lines are parallel lines, and the parallel line do not meet. And when they do not meet, it means they are not going to cross each other. And if they don't cross each other, there is no any specific point. So it is like infinity. That's what we call in math. So thank you very much for listening, and I hope you will enjoy the video. And subscribe to our channel, please, and then make sure that you watch all the videos and then try to do and solve most of the equation. Thank you very much. Have a nice time.